Assalamu alaikum and welcome to lecture number 13. Currently, you understand we are doing the convolution sum, right? So the next topic will be the convolution integral, right? And you understand we are doing it now using the graphical method. So in case of graphical method, we plot the two signals, that is response signal and the input signal, and reflect one of the signal, whether right, it's up to you whether you reflect and shift the response signal, or you reflect and shift the input signal, right? So in any case, the signal you want to reflect and shift, you should use a separate paper, right? Because in the convolution, you understand, we move the signal that is reflected and shifted, right? So we slide it. So if you make it on separate paper and then you slide that paper, it will be very easy for you to find the convolution, right? So you can easily know that whether we have the non-zero overlap, or we have the zero overlap, or whether the new interval of the convolution is starting or it's the ending or whatever. So the best practice is that you tear a piece of paper and you draw there the signal that you want to reflect and shift, right? So you should keep this practice for both, whether you are using the continuous time uh, case, where we will call it convolutional integral, or you're using the discrete time case, which we call them convolution sum. So let's start where we left. So it was this problem. Now we are given input signal x of n and the response signal h of n. Input is, as can be seen, it is from it exists from 0 up to 4, and it has constant value of 1, whereas the response exists from 0 n equals to 0 up to 6, and it has value of alpha power 1, where alpha, as given here, is greater than 1. That means this is an exponential signal, and from alpha power n you can say it's an exponential signal, but because the value of the alpha is greater than 1, that means it is an exponentially growing signal. So using the graphical method, the first step is to plot the two signals. So here we are plotting the two signals. It can be seen here that first we plot the signal x of n, and it has value of 1 from 0 up to 4, right? And the second step is to plot, okay, the first step is plot both the signals. So this is x of n and this is h of n, because it is given that alpha is greater than 1, so that means it will be an exponentially growing signal as plotted here, right? The second step is to change the variable from n by k. So now you have x of k, and here the independent variable is k. Again, we do the same thing for the response signal, which is h of k, and you understand h of k here, it was, we can write that h of k basically equals to x of h of n basically equals to alpha power n. So now we have replaced the variable, so now it will become alpha power k, right? So this is so the next step is to replace k by minus k, that is reflect the signal, right? You understand, we can reflect any of the signal. We can reflect the input signal, which is x of k now, and we can also reflect the response signal, which is now alpha power k. So let's reflect k. So to reflect k, we will get x of minus k, right? This is x of minus k, and you understand when we reflect a signal, we basically obtained its image around the vertical axis, right? So that means we can do it like this is the original signal, right? So we can say we put a mirror here, and if we look at into the mirror from this side, we can see that the signal at 0, right, it remains the same, whereas these signals, they will be shifted towards this side, which are shown here, right? So the signal originally existed at 0 is same, but the value existed at +1 now will be at -1, at +2, at 3, and so on, right? So because the signal exists from 0 up to 4, so now the reflected version will have value from 0 up to -4. Similarly, looking from this side in the mirror, you can see the values along the negative axis will be imaged at this side, because all the values on the negative axis, they are 0. So we have here the 0 values, right? So this is the reflected version of the signal x of k, which is now x of -k, right? So the third step is that because now it is shifted to the left side, right? Signal exists at negative side, so that means adding a negative value to the independent variable will make the signal shift towards the left side, this side, right? So that means we have some negative value, for example, generalized negative value n. So n has some negative value, so it will make it shift to the left side. So the resulting signal will now be like this. Originally the two signals, they were, right, this existed at 0, and this one I mean from 0 to positive this side, and this signal is from 0 up to this side. But after reflecting the x, now it exists from 0 towards the negative side, that is from 0 to -4. Right, and after adding a negative value, a big negative n will make the signal shift, will make the x of -k shift towards the left. So if I plot the two signal, now you can easily observe that this is your response signal, which exists again from 0 up to 6 as it was, because we haven't done any operation here, but we have performed the operation of reflection and shifting on this signal. Now this is your x of n minus k. So it can be easily observed that the signal is shifted to the left, right? Originally it exists from 0, this is 0 to 4. After reflection, these signals shifted this side, reflected this side, and after adding a negative value, now they are shifted to the left side. So if you compare the two signals, you can easily observe this. Okay, so this is the next slide where we are showing you the original signal, and then the reflected and shifted and so on, right? And that's the signal where we were. So you can see the product of the corresponding values, right? Because this signal, you can easily observe, this is 0 here, this is non-zero here, so the product will be 0. Again, for these values, you see, from n up to positive infinity, all the values here, they are 0. So if you multiply these, although at some instances this signal is non-zero, but the input signal is 0, so the product will result into 0. So that means there is no non-zero overlap here, so convolution here will be 0 and the output will be 0, and this continues, you see. Okay, so the next step is to shift the signal to this side again, right? and then do the corresponding product, take the corresponding product and then sum them. So again, you see, by moving the input signal right in this direction, you see now n corresponds to -1. Okay, n corresponds to -1, so that means y of -1, again this will be 0. Why? Because these signals, okay, the input signal which is non-zero in this portion, so but the response is 0 here, so the product will result into 0 and the summation of the zeros will be 0. Okay, so again we see that y of n equals to 0 for what value of n? When n is less than 0, right? So that's a generalized statement, because whether n is -1 or n is -2 or n is -100 or n is -infinity, for all those values the non-zero overlap is 0, so that means it will result into 0. So in generalized statement we can say that y of n equals to 0 when n is less than 0. You understand, n less than 0 means for negative values of the n. Okay, so you understand, this is the short, that is S. So that's what we do in the convolution, right? So shift, right, this m means multiply and this s means sum. So okay, so for this shift we get 0, so now 0 value of y. Okay, so we shift the signal again, okay, so which is shown on the next slide. So when we shift it one more position, okay, this is the previous status where n is less than 0. Okay, so again these are the position where n is, okay, you see n corresponds to -1, so up to -1, although this signal is non-zero but this signal is 0, so this corresponding multiplication will result into 0 and we get 0 output. Okay, now in the next, when we shift this signal again one place to this side, now you see that n is 1, n equals to 0, and at this n equals to 0 we have x of n minus k, right, equals to 1. Here it is 1, you understand, right? And the response is also non-zero here. So what is the product? So product of the two will result, that is, we can say h of k multiplied by x of n minus k at n equals to 0 equals to, now this is at n equals to 0, this is equal to alpha power 0 and multiplied by x of n minus k, so that is also equals to 1. Okay, then for the other values this is 0, and before this the non-zero overlap is 0, so that means at n equals to 0 we have alpha power 0. Okay, so that means I can write here y of n equals to alpha power 0 for n equals to 0. Okay, so at n equals to 1, what will be the value? So at n equals to 1, right, that means we shift the signal 1 unit again to the right side. So the resulting two signals are plotted here. You can see that now we have two samples of non-zero overlap. So that means we have this is n equals to 1. Okay, so we have because n corresponds to 1, so that means n equals to 1. At this point, this is non-zero and this is non-zero, so this sample is multiplied. This one, you understand, alpha power 0, so we say this is basically alpha power 0, okay, plus alpha power 1, okay. So this is yn, and for n equals to 1, okay. Again, you can observe for n equals to 2, again you see we have 3 non-zero overlap samples, right? So which are these? So this one corresponds to 1 multiplied by alpha power 0 equals to alpha, because this one is 1, so straight away we take these values. So this is alpha power 0, this is alpha power 1, this is alpha power 2. So we can say for y equals to y of n equals to alpha power 0 plus alpha power 1 plus alpha power 2, and this is for n equals to 1, okay. So similarly, after shifting the signal one unit to the right, we again see that this is equal to alpha power 0 up to alpha power 3. So that means alpha power 0 plus alpha power 1 plus alpha power 2, right? Alpha power 0, alpha power 1, alpha power 2, and alpha power 3. So we can write it in generalized form. Or generalized expression that we can say y of n equals to summation, okay, and this is k running from 0 up to n, and this is alpha power k, okay. So why? Because if we observe from here, right, starting from here, because if n equals to 1, the summation is up to n, okay. So in this case, n equals to 0, so the summation will be 0 to 0. That means we get alpha power 0, okay. Alpha power 0 is same what if we put 0 here, so summing it from 0 up to 0, it will result into alpha power 0, okay. When n equals to 1, which is this next case, right, here n equals to 1, so we see the summation start, the non-zero summation start from 0 up to 1. Similarly for 2 and 3 and also for 4, okay. So if you look at this one, so from 0 up to 4, okay, the generalized expression will be this one. So because this mathematical representation, okay, is valid for what value of n? So this is valid for the values of n where n is greater than or equal to 0 and less than or equal to 4, okay. So this is the generalized expression for this one. Why? Because after 4, what will happen, this sample will cross the 0, so that means the non-zero overlap will not start from 0, but rather it will start from 1. If we move one more unit, then it will not start from 1, but rather it will start from 2, okay. So that means this expression is valid for this interval, that is 0 to 4, So again, starting from here, we can see that I think up to here we have done up to 3 and then up to 4. So up to 4 we have done. So let's start the next. What will be the value of y of n, right, when n is equal to or greater than 5, right? So again we can notice that very easily that y of n will be equal to you can see okay, so for n equals to 5 we have you see this is alpha power 1 alpha plus alpha power 2 plus alpha power 3 plus alpha power 4 and plus alpha power 5. So we can write alpha power 1, right? 1 plus alpha power 2 plus alpha power 3 plus alpha power 4, and this is for when n yeah, also alpha power plus 5 plus alpha power 5. Okay, when n equals to 5. When n equals to 6, so we again have alpha power 6 because this corresponds to this, okay, which is shown here. You see, if you multiply the two, so these are all 1, so we straight away this one, so that will be, if you look at this one, then it is something alpha power 2, alpha power 3, alpha power 4 and alpha power 5, and this is alpha power 6. Okay, so what does it mean if we look at this this one? Okay, if we look at this one and this one, we can easily say that basically y of n equals to which is the generalized representation. Okay, so y of n equals to summation alpha power k, okay, and k equals to what? Is it equal to 0? Is it equal to 1? Is it equal to 2? So if we look at this one, so that's the starting point for k, right? So k basically equals to 1 here, okay, and if you look at this one, k basically equals to 2 here. So is it equal to 1 or 2? So that means basically k equals to n minus 4, because n minus 4 is, if it is coincides with 1, then k equals to 1. If it coincides with 2 like here, so k equals to 2. So that means we can say k equals to basically n minus 4. Okay, and that's the minimum value of k. Like minimum value of k is here 1, right? Minimum value of k equals to 1, and what is the maximum value? That is equal to 5. Okay, so if we come here, what is the minimum value of k here? So minimum value of k here is 2 and maximum value of k here is 6. Okay, so that means basically the maximum value of k is equal to n. Why? Because if n coincides with 6, it is equal to 6. Okay, like here n coincides with 5, so k equals to 5. So that means we can say that basically this is equal to this, and this representation is valid from n, yes, n minus 4 equals to 1, or we can also say n equals to n minus 4 means n equals to 5, because n minus 4 equals to 1, you understand, right? N minus 4 equals to 1, so that means n equals to 5. Okay, so we can see n is equal to or greater than 5, and it is equal to or less than, because this is valid up to n equals to 6, because when you move away from 6 you can easily observe here that at 7 the input signal is non-zero, right? At 7 input signal, this one is non-zero but this one is 0, so that means beyond this we have some new representation, mathematical representation, so I can write it like this one, right? So that's the generalized expression. You can also do it like the one I did, that's y of n equals to alpha 1, alpha 2, alpha 3, 4 and 5, and then you say okay, for n equals to 6 this is equal to alpha power 2 plus alpha power 3 plus alpha power 4 plus alpha power 5 and alpha power 6. Okay, but this is the generalized, and the better is that you learn how to write the generalized expression, right? So this is the case when n equals to how much? N equals to 5 to 6. So for this case we have y of n equals to this one. So what will happen when n crosses the 6? So after 6 you see this one, when you again shift 1 unit, so you see now n coincides with 7, so at 7 we have 0 overlap, right? So the non-zero overlap is from 3 up to 6. It is from 3 up to 6. So that means we can say y of n equals to alpha power 3, right? 3 plus alpha power 4 plus alpha power 5 and plus alpha power 6 when n equals to 7. That is y of 7 equals to this, right? So how about y of 8? So again, if I move it one more unit, so you can see that this is 7, so this is 8, so now n coincides with 8, you can easily observe here. So at this point the non-zero overlap will be, because this is 4, so that's alpha power 4, alpha power 5 and alpha power 6. Okay, so that means we can write the generalized expression for y of n, and we say y of n basically equals to summation k running from, okay, and this is alpha power k. Okay, so k running from what will be the value of k? So if we look at here, you see that k equals to 3 here. Is it clear? Okay, at this point k equals to 3. Okay, so for the next point k equals to 4. So what is the lower limit of the k? What is the lower limit of this summation expression? So we can say that lower limit is actually n minus 4. If n minus 4 coincides with 3, then lower limit is 3. If n minus 4 coincides with 4, then the lower limit is 4. So that means we can say this is basically n minus 4. Okay, and what should be the upper limit? So the upper limit is 6, because if we have the lower limit around 3, it is at 6, because you cannot move beyond 6. Why? Because beyond 6 this signal is 0, right? This signal is 0, so the product will result into 0. So that means the upper limit is 6, and this representation is valid for what? For n is equal to or greater than 5 and n is less than or equal to 6. So for this we can have this representation. Okay, no, I'm mistaken. I made a mistake. It's actually, this is not for n equals to 6. Basically this is for uh, n equals to 7, right? Because it starts from here. Here you see the last was up to here. This new is from here. So if you look at this one, n coincides with 7, so it starts with 7 and it will keep moving. Okay, so you can shift it here, 1 unit here. So now you see it's n coincides with 8, so we have the expression that upper limit of the summation is 6. Why? Because if this signal is although crossing the 6, but because this signal is non-zero beyond 6 and this signal is 0 beyond 6, so the product will result into 0. So we have the upper limit as 6. Okay, so the range of values of n are n equals to, for n equals to 8, this is valid. Again, if you shift the signal one more place, so that means this is 7, this is 8, n coincides with 8 and 9. Okay, now it is n coincides with 9, so again this expression is valid. Okay, the upper limit is remains the 6, whereas the lower limit is 5. So if I move this one place more, so again you see here this is the last non-zero sample. Okay, if I move it 1 unit further, then you see this signal is 0 and this will also become 0. So that means the maximum is this one. So what is the maximum here? This is again we can say k equals to 6, and what is the value of n? So n minus 4 coincides with 6, so that means n minus 4 equals to 6, so that means n equals to 6 plus 4, which will result into 10. So this is valid up to 10, so we can write that n equals or greater than 7 up to 10, and we move from here, okay, which is shown here, one more step. Okay, so you see the response is not non-zero, but the input is non-zero, but the response is 0, so that means the product of the two will result into 0 and summation of the zeros will result into 0. So that means we can in generalized form write that y of n equals to 0 for n is greater than 10. Okay, so let's write the generalized expression for the output. So generalized expression for the output will be that first we find y of n, okay, and we see that y of n equals to 0 when n is less than 0. Okay, then we find that y of n equals to summation k running from 0 up to n, and what was the range of n for and this is alpha power k, and what is the range of n for this representation? N is equal to or greater than 0 and less than or equal to 4. Okay, then the next representation we had was summation k running from k running from n minus 4 up to n, and it was alpha power k, and this was for n running from 5, or that is n equals to or less than 5 up to n is equal to or less than 6. Then the next expression was summation k running from n minus 4 up to 6, and this was alpha power k, and the range of n was n is equal to or greater than 7 and less than or equal to 10. Okay, so when we move from 10, then we found that y of n equals to 0 for n is greater than 10. So that's the generalized expression for different values of n. So by looking at this, we can say that basically we can split the convolution sum into different intervals, right? So we have the first interval where we say there is no overlap. Okay, so the output was 0, then which is this case. Then if we look at this one, then we have the partial overlap. Okay, so in partial overlap, this is the range of values of n. Then the next interval was the complete overlap, right? So the two signals were completely overlapped. Okay, so which is represented by this one, and then the fourth interval was again the partial overlap. So I hope you understand the meaning of the partial. Okay, so and the fifth interval is no overlap or non-zero overlap, right? So if we look at this one, we can observe that in case of partial overlap, right, this is the partial overlap, right? So in case of first partial overlap, you see that the lower limit is fixed at some position, right, and the upper limit is variable, right? So the first the partial overlap is when the lower limit is fixed and the upper limit is variable. In case of complete overlap or full overlap, right, this is generally we can say, not always it's the case, because there will be some signals for which this is not valid, but in general we can say, uh, especially for those where we have bipolar signals, or the signal which changes its for some values of n they are positive, and for the other values of n that is negative, then it might have different expression. So the second interval, right, this we call the first interval, right, this is the first interval, which is which is 0. Then we have the second interval, which is partial. Then we have the third interval, which we have the complete overlap. Then again we have the fourth interval, which has partial overlap, and then again we have the fifth interval, right, which has zero overlap. So in case of first partial overlap, we can observe that the lower limit is fixed and the upper limit is variable, right? In case of the complete overlap, we have both the limits as variable, right? Lower limit is variable and also the upper limit is variable, right? As far as the fourth interval is concerned, in case of fourth interval, we have lower limit as variable and the upper limit is fixed. Okay, so if we compare the first partial with the last partial, right, that's partial overlap. So if we compare the first partial overlap with the last partial overlap, it can be easily observed that in case of first partial overlap, lower limit is fixed, right? Lower limit is fixed and upper limit is variable. Whereas in case of the second partial overlap, the upper limit is fixed. You see, here lower limit is fixed, here upper limit is fixed. Here the lower limit is variable, whereas in case of first partial overlap, the upper limit is variable, right? And in case of complete overlap, we have both upper and lower limit, they are variable. So I hope this gives you some idea. So here's another problem we are going to solve. Okay, so to solve the convolution, we need the impulse response and the input signal. But if you look at the above equation, you are not given the impulse response. Instead, you are given the y of n equation for finding the y of n. So let's find first the impulse response. So you understand what is an impulse response. Impulse response is the output of the system when the input is impulse. So that means we replace the output y of n by h of n, and we replace the input by impulse. Why? Because this is the definition of impulse response, that okay, so this is x of n, so x of n will be replaced by impulse, so that is n minus k. Okay, so if we expand this, you understand that k, sorry, this is not I, in fact it's k. Okay, so k running from 0 up to n. So if I open this expression, so this 1 by 4 is basically n scaling vector. So we have k running from 0. So when I replace k 0, so I get impulse of n. That means I should get something like this 1 by 4. Then again we have 1 by 4. Now this time we replace k by 1, so it will be impulse of n minus 1. Then we have, now again we replace k by 2, so it will be impulse of n minus 2, and then we get another term that's 1 by 4, and now we replace k by 3, so it will be impulse of n minus 3. So now we have both the impulse response, which is this one, okay, and the input signal, this one, okay. So the first step is to plot the two signal versus n, so you understand this is the impulse response and we also have the input. So let's see how. So by plotting the input signal, because it is mentioned that input signal equals to u of n minus u of n minus 10. Okay, so what does it mean? You understand the input signal is given in terms of the step function. So step function equals to 1 when its argument is equal or greater than 0, right? So that means u of n is equal to 1 from 0 up to infinity. Again, we have another step function which we call it shifted impulse function, and which is shifted by amount of 10 units, you understand, and not here is basically 10, so that means the signal is shifted 10 units because 10 is positive, you know, this is just from equation, right? So if you talk about n naught, this is your n naught, so n naught 10 means it's a positive, so that means it's shifted right. Okay, so for positive we shift right, and for negative n we shift left. So that means this is basically shifted right, so that means because there is minus involved here, so that means this function equals to minus 1 from 10 up to infinity. So if we take the summation of these two signals, this is 1 from 0 up to infinity, and this is minus 1 from 10 up to infinity, so that means from 0 up to 9 this signal is 0. So 1 minus 0 will result into 1, so that's why we have this signal equals to 1 from 0, right, from 0 up to 9. Okay, similarly for the response signal, I have shown you that it's equal to 1 by 4 for right. So I hope you can plot the signal. So this is the first step, we plot the two signals. The second step is that we replace the independent variable n by k. Okay, so here we have x of k, and x of k running from 0 up to 9 is 1, and for all other values beyond this, right, it is 0, and before 0, that is to the with the negative index, it is 0. Okay, similarly the response signal, which is h of n, is plotted right here. So that's the second step. Then the third step is that we shift any of the right, any of them, whether you like to shift the response signal or you want to shift the input signal. So that's the third step. So I have shifted the the response signal. So after shifting it, I get right. So I hope you understand how we shift. So okay, sorry, not shift, reflect. So after reflection, we get, previously it was 0 to 3. Now it is 0 to minus 3. These are only non-zero value for this signal. The rest of values, right, greater than 0 are less than minus 3, which are minus 4, minus 5, and so on. They all are 0. That can easily be seen here, right? So I have replotted the signal x of k here for your convenience. Okay, the next step is that we add some negative value in this signal. So you understand, when shift is negative, like here shift is positive, so you shift the signal to the right side. So if this is negative, then the resulting signal is shifted left side. So by how much? By a factor of n we shift it. Okay, so previously this sample was at 0, now it will be at and this one was at -1, so now because it's shifted by amount of n, so it will be at n-1 and so on, right? I hope this is very clear to you. Okay, so now the next step is that we multiply the two signals. So if you can easily observe that here this whole signal is 0. Okay, this is 0, so that means the product of these will be 0, and when the product is 0, after whatever is the product here, after product we take the summation, which will also be 0. So this will continue, and then okay, so 0, then what is the next step? Next step is you shift the signal, right? I asked you, I already told you that you can memorize this thing, that is SMS. That what does it mean? It means shift, multiply, and then sum. This is for convolution sum. Okay, so you shift this way. Okay, because shifting the other side, you know that it will not, shifting to the left side, you know, it will never have non-zero overlap. So for all values of the left side it is 0. Now you shift 1 unit, and again, so you understand, if I shift the signal up to here, right, so then at that point n will be equal to 0, and we will have non-zero overlap, right? So the first interval will be, the second interval will be like we have done this in the previous numerical example. So understand, we can split the convolution into different intervals, right? So you understand the first interval is, or the first split is that you have no overlap, right? The second is when you have the partial overlap. The third is when you have the complete overlap. The fourth is again the partial overlap, and the fifth is the no overlap, right? So in summary, we can say we can have 3 non-zero overlap intervals. So if you look at this one, you see when you at 0, its value is 1 multiplied by 1/4, it will result into 1/4. When you move one more place, right, so n equals to 1, at n equals to 1 you have 0 to 1 summation, then at n equals to 2, then you have 0 to 2 summation, at n equals to 3 you have 0 to 3 summation, right? But the moment you cross the 3, then the summation does not start from 0, rather it will start from n-3. Okay, so we can write the first one, the second interval. So we can say y of n equals to summation and k running from 0 up to n, and it is 1/4. One signal is 1/4, the other is 1, so that means the product will result into 1/4. So hope that's clear to you. Okay, so for such kind of problems, a summation where we have the constant, right, factor, where we have a constant value here, so we use the equation which is this one, right? So we use this equation for summation when we have something constant, right, where c is constant. So you understand what is a constant, right? So to find the summation, the equation is k running from m up to n into c, so it will be the constant and then times the upper limit minus lower limit, right? Upper limit minus lower limit plus 1. So in this case, if we look at look at the values of n for this interval, it will be n is equal to or greater than 0. You understand, before 0 the two signals are the non-zero overlap is 0. Okay, and the upper limit of the n will be 3. Why? Because up to 3 we have the partial overlap. The moment we cross the 3, we will have the complete overlap, and in this case the lower limit is 0, the upper limit is n. But the moment we have the the complete overlap, in that case we have the upper limit and lower limit both are variable. So this is valid for this, right? So in this case we can say that y of n equals to by putting values, so k running from 0 up to n, so this will be 1 by 4. Okay, that's your c, and then you have value of k, upper limit minus lower limit, so upper limit is n, lower is 0, so n minus 0 plus 1, so this simplifies to 1 by 4, and this will be n plus 1, and the values of n for this are n is equal to or greater than 0 and less than or equal to, right? Because up to 3 it's fine. After 3 it will the lower limit will change, because after 3 it will be, the lower limit will be not 0 but it will be n minus 3. So I hope this gives you the idea. I leave the rest of the interval I leave the rest of the intervals for you, and you must do it at your home and tell me your answers, what you get while in the live session. So that's all for today's lecture. See you. Allah Hafiz.